Thank you for coming. I'm so excited to be here today, B-Sides 2025, Budapest. So today we're going to talk about taking over Kubernetes clusters, specifically in the cloud, in AWS cloud, but it will be relevant for other cloud as well. Also talk about a lot of movement in the cloud from Kubernetes. And we have a demo by the end of the talk. So for everyone of you that doesn't know me, my name is Chen Shiri, aka the container guy. I'm known online as Black Doc. I'm a security researcher. I'm in the field since 9 years old. I'm specializing in low-level security and cloud and infrastructure, IoT. I love it. That's what I'm doing. I'm working in Accenture. I perform pen testing for popular companies. My hobbies are jiu-jitsu, Marvel, comic books, and but that's it for now. Chen Shiri, nice to meet you. And let's talk about Kubernetes a little bit. So a little bit about the agenda for today. So we'll talk about my research in AWS and new vulnerabilities in container-based environments. I explore my research into EKS, Elastic Kubernetes Service. This talk is focused on two different vulnerabilities and security issues that compromise the pod isolation mechanism. So before we jump to it, we'll have a quick introduction with Kubernetes, and then we'll explore the attack methodology that I've built to attack Kubernetes from a pod, from initial access to a pod. Then we'll talk about how to compromise it, specifically in AWS Kubernetes. We'll talk about two different security issues that exist by default in AWS and still active, that you can compromise it to take over clusters. Talk about bypass techniques that together with the two different security issues, it becomes an attack vector. And initially we'll see how they connect together to a whole attack vector to take over clusters. And then your favorite part, the mitigations, of course. So a little bit about Kubernetes. In a few sentences, container is a virtual machine alike, Docker is the hypervisor, and Kubernetes is the orchestration. And so basically what it means that the container is a light portable package that runs the application and its dependencies. The Docker, it's the engine, the containerization platform that provide all the necessary things to run the container. And Kubernetes, it's the open source system for automating and managing all of this. To scale it and all what's related to this. And now everyone are microservices experts, and as you know, in contrast to VM, containers are very fast, and that's why they became very popular. And today we have the architectural shift from virtual machines to microservices, and it brings with it new risks. And do you know why it's a game changer to the game changers? Besides the fact that they are fast, now every web application, when we look at the online AIs, ChatGPT for example, each session runs in a different container. So it brings it with it, as you can think about it, if you look at the business impact, business risks, every container runs its own customer data, own customer things, so it's usually need to be isolated. And why not? It's considered as isolated by default. So as I said, it becoming very popular with the CI/CD. Almost every architecture is utilizing containers because it's fast, it's considered isolated and secured, and especially Kubernetes. So a little bit more to understand the attacks, we need a little bit to know more about Kubernetes. So the node is the worker machine hosting the pods. The pods are the logical components that manage the container. And the kubelet is an agent that inside the node, it's usually considered, it's used to manage with the API, depends on the Kubernetes, to manage the containers and to validate that they're alive. And usually as it has a file also in the node that called the kubeconfig. It's been utilized usually for managing and to authenticate with the main API, the main node. It depends, as I said, on the architecture of the Kubernetes. Namespaces, it's a mechanism for isolating group of resources, group of pods into a single component in the cluster. Why it's so critical? Because some companies use it to separate, for example, from production to non-production, or from customer data to non-customer data. So it's need to be isolated and to not be accessible if it's from networking aspect to move between namespaces. So the control plane. So in some architectures we have the master node, some of them we have the control plane. In the cloud, for example, it has inside the Kubernetes API server. It's the most critical component of the system. It's used. There are many attacks on it. Brute force attacks, denial of service. Usually developers and attackers use a kubectl tool to authenticate to it. And now let's talk about the chain attack. So a little bit more background about Kubernetes. It's originally an open source of Google, but today it's more than that. Today Kubernetes is a beast. This open source was integrated in almost every cloud. We have it on AWS, its own integration, where Google, Azure has its own integration to it. And so today we'll talk about two security issues that exist by default. And it allows to even with limited permissions on the pod to get access to the API that we talked about. So this is our architecture for today, for today's demo. We have two different namespaces. It's one of the popular architectures. We have one for the front end, one of the back end. The attacker has access to one limited container. If it's from a some chat or session that he got access to one container, it's considered isolated. It's a default container. It's don't have any changes or something. As you can see, we have here also the ECR that contains all the container images. We have the metadata instance. We'll talk about it later. So, just a second. So, as you can see, there are many ways to break out from containers. We're not going to talk about anything of this today, because, as I said, like today, it took 10 years to get to this stage, but today Kubernetes is by default very secured. And unless there's any developer mistake or anything, or if it's a Docker CVE in the runtime itself or kernel issue, that I know that almost every company is making sure to have its own upgrades to the containers, to the images, to not have some kind of vulnerability. So it's not very common. Open ports and things like this. Also, today it's best practice. It's not very common anymore. So it's not very easy today to break out from container as it was in the previous years. It took 10 years, but by default, it's now secured. So this is the attack methodology that we'll use today to attack the clusters. We'll start usually an attacker search for some kind of service account or API that he can utilize. As I said, it doesn't exist by default. Some containers, because this is how networking is managed in Kubernetes, they're implemented inside the cluster, but they know that it needs to be secured with limited privileged access. Then attacker can perform some kind of enumeration. If it's on a different container, some containers are considered more central containers. They have, for example, Kafka servers. Attackers want to target them to get more information. So even communication between pods need to be secured. Then like the attacker want to try to get to utilize the access to this service account to get more access. If it's to the stronger service account, some kind of credentials, to get access to other platforms, if it's the cloud, and then to get a foothold if it's on the cloud or the cluster. So this is the methodology that I've created using those two issues that I'll talk about during this presentation. First, we'll get access to the node IAM role from the container using the metadata instance. Then depends on its permissions, we'll continue, whether it's default or not default. If it's you can utilize it to pivot to the cloud using technique. We'll be less focused on this right now. Focus more on taking over the cluster. Then you have these two scenarios that we'll talk about. If it's getting access to the data of other containers, or using generating a new API token to take over the cluster or other containers. And we'll see how we're going to do that. So the metadata service exists on almost every cloud today. It's different between every cloud. It's usually provide access to configurations in the cloud and for integrations. For example, if developers want to integrate some services behind the scenes, it's being performed usually using the metadata, or to validate that keep alive with the VMs. So in the two recent years, it became one of the most popular attack vectors in the cloud, and it's also because in web application you can utilize it. So AWS came with the new metadata and metadata v2 and their mitigation was to use put requests. I will not be focused on this. It's not an AppSec talk, but there's an GoPro protocol that you can do a put request over HTTP, and this is how we still can utilize it in all those attack vectors from a web application perspective. And it's still dangerous from this perspective. So as you can see, usually it exists also in EC2, but in the regular EC2 I found that you can, with the default one, you cannot do a lot of things unless the developers implemented some kind of integrations. So beside the EC2 role, the default is secured. I said you have the integrations, but it's not by default. So as you know, the EKS use a regular VM, virtual machine, for running the containers inside. But the role of the node of the VM, virtual machine, that it's the node of the Kubernetes, it's not the same role. To keep all these beasts of the Kubernetes alive, it has different privileges, different default privileges. And it's mainly for interacting with the main the controller and the main API, and to manage the cluster. And one more thing to note: Kubernetes relies on many third-party plugins, add-ons, integrations, monitoring. To implement all of this, you need to give this specific role more permissions, and that's what's common today. So it's going to be much more privileged than what we're going to talk about today. And when you give it more privileges, it will make the role of this node more privileged. So let's talk about the first issue, this metadata role. The metadata instance of the host, of the node, is accessible by every container by default. So this allows us to get its token from the metadata. And using the token, we can get, first we can perform enumeration. I found that you can get all the information about other nodes that running on the cluster. This is how, without scanning all the subnet, you can know what's the subnet and the security groups in the cluster. We usually need it for the name of the cluster, for the attack. As you can see, by default, it gives the security group, it shows you the security group with the cluster name, so you don't need to guess it. You'll have it here. And you have all the subnet of the cluster so that you can, now you know them and you can just scan them. Using the token, I got the role of the cluster, of the node. So when we look at it more on the assume role of this role, you see that it belongs to a special user that in system nodes. And this is a special Kubernetes group which have read-only permissions on config maps, pods, Kubernetes configuration, even PVC and PVs, that it's some kind of storage in Kubernetes. And it's bound to the kubelet node that we talked about. And one thing to note, as I said, different Kubernetes implementation has its own integration. This is how AWS chose to manage it. And there's a problem. By default, it has, I saw that it has limited permissions. I started to research what can I do with it. So first of all, I saw that I can get the tags of all the environment of the AWS using the default this role of the Kubernetes. You can see what components exist in the cloud. Though you don't have access to them, you can now know what exists on the cloud, and you can see from the value it gives it the default name of the component. So you actually can know, again, from here you can know, it's another way to know what's the name of the cluster, and you can know what components exist. Additionally, we can list instances. We cannot enter them, but we can list them. But this one can be blocked. Some things here, like this, cannot be some things cannot be blocked. Another interesting permission that I saw, it has authorization to get, though it's not, you cannot enter containers by default, you can get you can authenticate with the metadata, with the ECR, container registry, and to get the images of all containers. And after you download them, you can get to see their value. So this is how you authenticate with them. You can get the login passwords, and you get the repository name, and after you pull it, you can access and build run the container from the image, and you can even see all the layers. Usually it contains credentials, data of containers, even databases. And this is how we can get access to the data of the containers without even have the privileges to enter the container. As you can see, it shows usually how the container was built, developer notes. Many times it contains your passwords and how it was built. But we want something that works every time. So, but we'll focus on some different vectors, but it's one vector. The second issue that I found that you can generate a new kube config from using this role. As you can see, we use the name of the cluster that we know right now, and also the region that we gather from the metadata. And now we can see that we have a new kube config with read-only permissions on the cluster. So another issue that I saw that it has read-only access and even limited read-only, not on everything. And here I used different techniques that are that I found with the years. Kubernetes bypass techniques. This works. It works. You can do it with every service account that you found. This is considered a security issue because, and the problem here, it's considered features, but it's an issue just because it's performed from the pod. And unless you have some kind of implemented service account or something that's created by the developer, you cannot get this kind of information. So they're not bugs. It's a feature. It's features, and it's an issue just because it's connected with all the vector. So the first issue. So we're going to do. So the techniques mainly are going to be viewing information about and details about all the containers that are running in the cluster, the Kubernetes manifest. We'll see how we can enter to some containers and taking over pods. So first, as you can see, I couldn't list namespaces. So, but we can get services. So using get services minus all namespaces, we actually can see all the ports that open in the clusters and the names. And now we can list the namespace, and we can know what's the namespace, though we don't have permission to list the namespace. So it gives you this information. Now, after you know this, you can use get minus n get pods. You can type the name of the namespace, and now you can see all the pods in the namespace. You can also, now you know all the open ports without scanning. You can use it as well from the pod that you breached. Another issue that I saw, I don't have access. We want access to all the configuration that contains the environment variables, secrets, things like this, and you don't have it by default. Just to remind you, we're still using the default service account. So though we cannot list deployments, we can show the runtime configuration that equivalent to the deployments using minus all YAML. And now you can see all the environment variables that contains the integration information, usually secrets as well. As you can see, you also can know what's the name of secrets that mounted. And once you know it, as you can see below here, you can use the name of the secret with this technique to get the value of the secret without having the secret's privilege that we saw previously, that we don't have it. But we can get the secret's name. So with this technique, you can still get the value of the secret, as you can see. And it's with the strong encryption of base 64. So you can just utilize it. So for the research, if you don't have the exec found that many times you don't, and like this scenario, you don't have the permission to enter containers, but you have permission to create new containers. And this is because it's the kubelet permissions. This role has the same permission as the kubelet, and usually you can just create new containers and not enter new ones. So I wanted to take over the cluster. I wanted to get into existing containers. So first I saw that we have a few options for this. First, one way is to, in some cases, you can, if config maps are implemented and you have this common permission to update them, you can edit the config maps and with the code execution. Usually it contains configuration that runs automatically in the cluster, and you can inject a command here or malicious scripts to get access to the container. So this is one way to enter containers without having the access. And another way, and more interesting, it's create a vulnerable pod. So in this case, we don't have access to the containers, but we can create new one. So what I did, it's I used ngrok, tunneling service, and I pre-built a container that automatically runs and activates ngrok tunneling, and it connects to with my credentials to my ngrok, and this is how I can get access to the container without enabling any network service, but usually you don't have access to a new network service, or accessing the pod. So I create SSH and ngrok. As you can see, I created the new pod that I can deploy as privileged, because after accessing the container, I want to break out to the node that contains all the interesting information. And one more issue that I saw, that I couldn't get the address of the tunneling. so because I don't have access to see the output of the command. But though we don't have access to the container, we have access to the logs using these default permissions. So using this command here, I made sure that I can get the address from the logs of the ngrok to connect it. I make sure that it's been logged because it's not logged by default. As you can see, I created the vulnerable pod. I used I checked it in the logs. I can see the address. I just logged in SSH and it worked. Now you're in a container, in a new container in the cluster. And one more thing, you need to specify the node of the target node that you want to breach, because there are many nodes in the environment of Kubernetes. You need to deploy this container in the target node that you want to access to. Because if you're in node 1 and you want to access node 3, you need to deploy it on node 3. So now we have a new container and a node and another node, and we want to breach all the pods in this container. So this pod is privileged, so I just utilized the privileged container flag that I activated to break it from the container. It's a very common attack. And as you can see now, we have access to all the containers inside this node. If it's all their secrets, all this information, and more interesting than this, we have credentials here that we can utilize, that's being utilized by the node. And this is how we took over it. And you can see the attack demo here. Just a second, please. See, we're in the breach container. We can see the C groups of Kubernetes, that it's a container. Now we're accessing the metadata service. We're performing enumeration to know what's the name of the cluster, security groups, if we want to scan something. We can see the region that we'll need to use it. Now we configure, I configure in my local machine the role that I gathered. Check what permission it has and that it works. Get caller identity. Now we can see all the tags. We create a new kube config to get credentials to the API. It worked. We check its permission. We came from the front end. We still can see pods from the back end namespace. This is how we can see the secrets of other containers. It allowed me to see all the secrets of all the cluster. So you can see, I can create pod. I had the permission. You can see that where it's mounted, what disk. Now we mount the host in the container. And now we are inside the host, and we can access all its files. Now we can see its kubelet credentials. It's containers on the host that has the secrets. So how to mitigate this? The recommendation to block the metadata from the containers, to reduce the EKS permissions. By default, it's limited. You cannot. It's not fixing it. So you must block it from the containers to fully mitigate it. And third-party protection service that detects enumeration on API calls of Kubernetes. This is also very important. To get all the files that I used, the vulnerable pod that is very useful for attacks in Kubernetes. You can use it on every API, on every service account. You can scan the barcode. Soon, we're going, me and my colleagues, to publish a new tool of kubekiller. It works on every Kubernetes, so you can stay updated to get access to it. And other points for research, I saw that this access, even if you drop the access to the pods to create new pods, still it has, and the kubelet has permissions to create new mirror pods, and those are special pods that used to troubleshooting by the kubelet, and you cannot drop them, the mirror pods. And this service account, the default one, has access to it, and potentially they can be deployed for exploitation with the same technique as privileged. This is another point for research. Do you have time? Okay. So other point for research, as we said, every cloud has its own implementation for this communication and managing the cluster. This is how Azure chose to do it. They has two types of authentication. They have managed identities and service principal. Not get into managed identities due to time. You can read it in my blog. It's has the similar concepts and issues, but service principal, it's automatically has credentials on the host, and after you get access to the host, if it's a privileged container, you have this JSON file in this path, and it has very strong permissions on the cluster, much more than the kubelet needs. And you can remote code execution on every node using it if you get access to it, from what I found. As well, and if in the other end, if you implement managed identities, you use it to integration in the cluster, or you can utilize it from the container. So both things are not secured. If you want to read more, you can read it in my blog. And thank you for coming. If you have questions, feel free to ask.